Hello, welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma, and today we have a very special guest. It is Arek Borucki, who is the author of MongoDB in Action. Hello, Eric, how are you? Or Arek, sorry, it's Arek, right? Just want to make sure I got that correctly.
Hi, this is Arek or Eric, so both forms are okay. I'm very happy that I can talk to you today.
Yeah, it's great to have you on because, as you can see, I've been poaching a lot of authors from Manning. Luckily, they reached out to me and asked if we can get some authors on, which is great because I haven't had a time to find some more proper guests. But I think every guest I brought on has been giving an interesting feedback about different things that I think are related to Flutter. And so, one thing I've seen a lot of is that basically to for databases, like people also ask questions like, which database should I use? Should I use Postgres? Should I use MySQL? Should I use Firebase, which is a big one? There's already a connection with Firebase and Flutter. And MongoDB has come up quite a few times, especially with people who are doing JavaScript backgrounds. So if they're doing something with Express.js, then they may actually just use, MongoDB, which I'm not too sure why that is, but I guess because JSON, BSON, and the fact that MongoDB takes JSON directly, I believe that it just makes more sense. But then again, you know much more about MongoDB than me. I have a little bit of experience that I may bring up, but it would be interesting to hear from you about, your thoughts on MongoDB. Obviously, you're pro MongoDB. If not, I would be a bit surprised. And why don't we just kind of talk a little bit about your background so that way we understand, like, who is this guy and why is he an authority on MongoDB? If you mind to kind of give a quick introduction of yourself.
Okay, hi everyone. My name is Arek Borucki. I'm originally, I was born in Poland, but I moved to Germany 10 years ago. Currently, I'm in Munich, Germany. And I have been working with MongoDB products since 2016. I'm MongoDB champion since long time. Also, I'm the author of two books about MongoDB. Actually, my first book, Mastering MongoDB 7.0, I was one of the authors. So I wrote 5 chapters for this book, but now uh, I decided to create a book alone together with Manning, and this is from where MongoDB in Action 8.0 came from.
I mean, it would be interesting to hear a little bit about why you got into writing a book about MongoDB. Like what because it's a big effort, right? And also, it you mentioned to me before we started recording, which is that so this is the third edition of MongoDB in Action. The first and second, I'm for sure the second, but I don't know about the first. I'm guessing probably not. Was not in any way written by you. The third one, I believe, is 100% by you. So, what kind of prompted you to get into this? Because usually editions are the same author, or at least one of the authors are kind of coming back. That's my understanding. So, I'd kind of like to understand a little bit about how this went down that you're doing MongoDB in Action, the third edition.
This is very good question. Actually, I started talk on MongoDB conferences like 6 years ago. I went to China once, so it was really amazing trip. I was able to be main speaker at a China event. Then I went to the US couple of times, to the UK, and someone from Manning approached me via LinkedIn if I would like to create something like a book. Uh, I rejected first proposal, but after a year, I was thinking that maybe I made a bad decision, and I contact Manning back and I ask them if they are still okay with me and with book about MongoDB. This is how it started, and you are right. This is huge effort. Book has 650 pages, and this is not easy to create everything alone. You are basically writing in every weekend, in every evening after work, because obviously I have a full-time job, so I need to work from 9 till 5 p.m. every day. So you have time for nothing if you are creating a book. But when you see that book is almost finished, you feel huge satisfaction. You feel huge satisfaction, and at least I hope that people will also like this book. I want to mention that currently, because the book is completed, but currently MongoDB is doing technical review. MongoDB was so kind that they offered me technical review, and also they helped me with illustrations. So I didn't have to create illustrations by myself. In every book you must have some illustrations if you want to explain something. And in this case, I didn't have to create them alone. I have them from MongoDB. This is really, really great to have such support from Mongo.
That's pretty interesting. How did you get into that? Is it because I see your shirt, it says community champion, so you're in some kind of program where you have this tight relationship with MongoDB, is that right?
Yes, yes, yes. Actually, I'm one of the first champions. This program started in 2020. MongoDB contacted me, and then they asked me if I want to be part of the MongoDB Champions program. I was before MongoDB Master. I think it was in 2018. MongoDB gave me MongoDB Master title, and 2 years later, when they created this Champions program, I was also involved. Currently, we have, I think, around 35 champions. This community is growing. We are creating some blog posts for MongoDB. Sometimes we also talk on conferences. For example, I like this. I like to go in front of the audience, not via internet, but really in some conference, and then just talk about performance, about sharding, about best practices of using MongoDB, or about, now my favorite subject is running MongoDB on Kubernetes. So this is from where champions came from.
That's a very good question because I'm more into Postgres, and I tried to run a database on Kubernetes, and my experience was not that good. I'm not going to get into all the details, but basically, I came to the conclusion that running something that's not ephemeral, like a database, on something that's Kubernetes, which is basically ephemeral to a certain extent, it seems like not a very good idea in my opinion. So I tend to use like cloud service hosted DB, and my apps run on Kubernetes. Since you brought this topic up, since this is also something that you're interested in, can you talk more about why you think this is a good thing?
This is a very good question. Also, I need to mention that I like Kubernetes. In Kubernetes, you have object called stateful set, and you can run stateful applications together with stateless applications. Yeah, so your application can connect to your database, which is also running on Kubernetes. You have persistent volumes. This is where your database will store data with the help of stateful set object. And the best practice, if you want to run any database on Kubernetes, not only MongoDB, don't do this by yourself. Use an operator. An operator extends Kubernetes API by technology-specific objects. So, for example, you can have deployment, you can have service, but also you can have replica set object if you install operator. And then in your YAML file, you only specify your desired state or your cluster. If we talk about MongoDB, you need to install a MongoDB operator. This MongoDB operator will extend Kubernetes API and will take care for entire setup for you. You only need to specify, desired state. And then this operator will create stateful set. This stateful set will request persistent disk, for example, from cloud provider, and your database will store data on this disk. I can say that this solution is getting very popular. I spoke to one company in Germany. They are running MongoDB on huge scale. Actually, I spoke to them 2 weeks ago, and everything is on Kubernetes. So they have like hundreds of terabytes of data, and they are not doing classical management in data center, with Ansible, with shell scripts, etc. They simply use Kubernetes operator, and and they let Kubernetes and operator orchestrate everything which is related to database. So I think this solution is getting popular and will be more popular in the future, simply because it's saving a lot of human time, and you don't need to have really specific knowledge on how to run database like MongoDB, because operator has all the best practices hard coded.
Okay. Yeah, I did remember about operators, but I never really got into them. I think I saw a couple of tutorials about how to create an operator, but I never really understood what an operator was other than it was kind of like a high level, kind of remind me of like a Helm package that can just install everything that you need. But aren't operators, they mean they must be specific per project, I mean per like product and per cloud provider, no? I mean they're not like universal necessarily.
Uh, yes. This is true. They are not universal. If you Google, you will see operators for MySQL, you will see operators for Postgres, for MongoDB, for Apache Kafka. For example, in my current workplace, I'm running Apache Kafka on Kubernetes. So operator, basically, that's a pod. If you are installing operator via Helm chart, you will see additional pod, and this pod will be running in some namespace. So for example, MongoDB namespace or Apache Kafka namespace. And if this pod will be up and running, your Kubernetes API will support additional objects like Apache Kafka, if you run Kafka operator, or replica set if you run MongoDB operator. And then you can simply use YAML file. You will specify object kind replica set, number of replicas 3, disk size, and you can deploy this database with kubectl apply, for example. You can have different namespaces, and you can run different data store technologies in those namespaces. You need to only have separate operators for each technology.
Okay. All right. I'll have to take a look at operators and to see if this is something that's useful. But I would like to talk a little bit more about MongoDB itself, right? Because I'm not sure if things have changed so much yet in terms of CS classes and in even other tutorials and things like that. I mean, MongoDB is probably one of the most, maybe if could be the most popular kind of document based storage database out there, right? There's different kinds of databases. There's graph, there's document, there's SQL, kind of tabular data. There's probably some more out there that are not coming to my mind, but since I think SQL and with tables and everything like that, that's more popular. People probably teach that still in school, a lot of tutorials. Can we talk a little bit about how does MongoDB compare to say Postgres, MySQL, MS SQL, these kind of more traditional SQL based databases?
Yeah, sure. So I see two differences, maybe even three differences. So first one is document model. I know that Postgres also can use JSON, but let's focus first on MongoDB. So this is document model and flexible schema. So you don't need to predefine your schema like you are doing in MySQL, for example. You can insert data to MongoDB straight away. If collection or database doesn't exist, MongoDB will create this collection for you. However, you need to remember that schemaless database also needs to have some kind of data modeling. You really should not insert everything to MongoDB. Simply because your documents can become too huge. Maximum document size in MongoDB is 16 megabytes, but this size should not even be close to this maximum document size. So you need to think what really you want to store in your documents. It's not a good idea to insert everything, to put everything, all data, even data which is not needed, to one document. Basically, data accessed together should be stored together. And in your document, you should only have data which is needed for a query. And then in one query, you will get this document, and this query will be extremely fast, not like in classical relational databases where you need to join a couple of tables. And those joins, if you are joining data from multiple tables in order to get some results, they are very expensive. That's why those kind of databases are slower. So this is one of the biggest advantage of MongoDB is document schema. Also, if you want to change your schema, you can do this very easy and fast. Not like in classical database when you need to use alter table. Sometimes you need to have downtime because you need to migrate your schemas to new schema. In MongoDB, not. In MongoDB, you can very easy just create new collection and store them their different kind of documents. And this is it. Maybe let's say something about best practices. There is something called schema validator. You should use those schema validators because sometimes, for example, if you have an array in your documents, those arrays can become too large, and then you can have performance problems. So I would recommend, if you use MongoDB flexible schema, use also schema validators. And those validators will be checking if your document has correct values or if your array doesn't become too large. You need to think about this, especially when you are running MongoDB on production. Second thing which will differentiate MongoDB from classical relational databases is sharding, horizontal scaling. Now, some applications need to have really huge amount of data. And for example, if you have Postgres and your data set is growing, you can only add more CPU, more disk, or more memory to your server. So you are scaling vertically, but this is not endless. At some point, you will just get maximum size of your machine, and this is all. In MongoDB, you can scale horizontally. There is a feature called sharding. You can use plenty of servers. In my work experience, I was running MongoDB, which has 120 terabytes of data. So this cluster was distributed across 85 physical machines. Data was divided into shards and stored separately. So each part of data was running separately, dedicated server, of course, with replica set. And this setup was working pretty well. And I think if you really want to have database for big data, MongoDB is better from traditional SQL databases. You can't scale those databases because they are using joins. Joins are expensive, and also it's very hard to horizontally scale databases which are joining data from from few tables. So I think those 2 points are the biggest differentiation between SQL databases and MongoDB.
Yeah, I remember working with employer, and he always told me, okay, we can use SQL, but just never do join, never do join. So that's why your comment came up in my mind about the join being a problem. So that's interesting that you brought that up. Is I remember when I was working with Firebase, right? Because that's the most thing I've probably worked with in terms of document-based storage, is that if you do have this and you have the data in multiple places, and one of the negatives is that you have to update all these different places, right? Because sometimes you want to have a table of users, sometimes you want to have a table of like maybe the possible roles. You copy the role name over, maybe when you update the user, but then maybe you change like admin to administrator, then you want to go through and you have to update both in this collection and the other collection. What are your thoughts about this? When you have this kind of multiple copies of the same data in different places, and how to manage that?
Yeah. So data duplication is possible with MongoDB, and then your application needs to take care of this. Yeah. So this is like when you are thinking about your data model, you need to take this into account, and you need to think if you have to update all those documents. Maybe you want to keep some historical values, and not all documents will have to be updated, etc. So this is data modeling part. In my book, there is a chapter about data modeling. But you are right. In MongoDB, data duplication can exist.
Now, is there anything in the recent versions of Mongo that can help with this? I think you said you mentioned that there is something that can help with this, or this is something completely on the application side.
This is completely on the application. New MongoDB 8.0 is much faster than previous versions of MongoDB. There are some architectural optimization according to is 36% faster in terms of reads. There is 60%, you can have 60% more throughput on this database, and much faster inserts. I didn't do those benchmarks by myself, so I have this data from official documentation, but this is at least what MongoDB is saying about 8.0. But data duplication won't be fixed by this. This must be done on application side.
Now, the other thing that so I guess now it's time for me to talk about my little MongoDB story. I used to work at a finance vendor. I won't say the name because it's a little bit embarrassing. Where, when you work in finance, you always have to justify changing the schema. And when I arrived there, they already had some data stored in MongoDB, and I asked them, why is that? Because traditionally you would use, this is way a long time ago before we had ACID compliancy in MongoDB, and they talk about like, oh, you have to always talk to the DB admin, prove your case, and then they're going to change the database, and it's could be problems and stuff. So they like to use MongoDB because they could just write whatever they wanted to, which that's always a it could be a big problem, right? If you're not safe. But what I wanted to bring up was some of the bigger changes that's happened since then was ACID compliancy. That's been some time, right? It's been what, at least 5 years since it's been ACID compliant.
Yeah, this is correct. So ACID is nothing new. So you
Yeah.
can have in MongoDB multi-documents transactions now.
Now, for the ACID compliancy, right? When you keep talking about MongoDB 8, right? The reason I brought this up is because ACID was a huge thing that people started getting some validity to it, because there was some people talking online saying it's not ACID compliant, therefore it's not something I want to take a look at. Maybe we can talk a little, since we keep talking about ACID compliancy. I'm guessing people may not always know what that means. Do you mind to kind of go over that?
So this is basically transaction, same transactions like you have in SQL databases. It means your data will be consistent in database, even if few applications are modifying the same document.
Yeah, so that's the big one because it's like if you have a transaction, you have many different statements you want to do at once. It's either all or nothing, right? Which is something that you usually want because you want to have, especially in finance. If you go back to my original issue, you take money from one account, put it to another account. It's going to be at least two writes in there. So you don't want to just take money from somebody and not credit to somebody else. That could be a problem, right? Or even credit and not deduct. That's even another problem. You're just creating money out of nowhere now. So it's really quite important. Where this kind of came from is that I keep hearing you say MongoDB 8, MongoDB 8. It's the newest version that's either out or coming out. Can you talk a little bit more about MongoDB 8 and why this is something that kind of keeps coming up? I keep hearing in your conversation today.
So the biggest change is performance. So this database is much more faster than previous versions. So this is one big change. Second big change, if I'm thinking about this, is related to sharding. So this is when you are horizontally scale your data. And then if you want to shard your data, you need to choose shard key. And this is not easy task. Shard key is something like an index, and MongoDB will decide based on this key on which server your data should be stored. And in the to choose big experience and knowledge about sharding. However, in MongoDB 8.0, there is shard key recommender. And I was testing this, and I really like this because this recommender will give you recommendation about shard key which you should choose. You need to provide some input data like type of queries you will run, what kind of data will you have, etc. But at the end, you will get very good recommendation about which shard key should you choose. And then you need to create an index which will correspond to the shard key. And after this, you can enable sharding, and MongoDB will be distributing your data across multiple servers. But what if you want to change shard key after a couple of years? You will see that maybe it wasn't the best decision, your data has changed, your query patterns has changed, and you want to change shard key. In the past, it was really painful because you had to do something similar like schema migration in SQL database. But now this is not in 8.0, it came in MongoDB 7.0. There is live resharding feature. It means if you want to change your shard key, this is not painful anymore. You will use one command which will change the key. However, you need to be careful because this operation is really resource intensive, and I wouldn't do this in peak hours. I would do activities like resharding in weekend or in some bank holidays, where people doesn't use your application because it can be problematic. But yeah, this is possible. I just want to mention that this book, MongoDB in Action 8.0, is not only about core MongoDB server, because now we talk only about core MongoDB server. There is also MongoDB Atlas. So that's a cloud platform. This is MongoDB in cloud. You can run MongoDB on premises. So you will have core server for MongoDB with all those features which we were discussing. But also you can use cloud version of MongoDB. This is Atlas. And Atlas, apart from automation, which will help you to set up your database in cloud, which will help you with upgrades, which will help you with performance issues, because Atlas provides you very nice monitoring tools and charts. Also, there is something called schema anti-pattern detector. I call this detector because you can, in Atlas, you can check your documents and Atlas will tell you if your documents are okay, or maybe you should change something in your documents, etc. So this is very nice tool for someone who doesn't have deep knowledge about schema design. But I wanted to say that Atlas is extending MongoDB core server capabilities, and Atlas is adding additional features to MongoDB. Like, for example, full text search. Yeah, full text search is, I think, this is very interesting features for many applications now, because it allows you to use, for example, fuzzy search or Boolean search or proximity search or even vector search, which is getting very popular since OpenAI announced ChatGPT. Yeah, so all those features which are not available yet, I will tell about this in a minute, which are not available yet in core MongoDB server, are available in Atlas. So if you want to use full text search, you will enable this feature in Atlas. MongoDB will create search index based on Apache Lucene. So this full text search in Atlas has been created on the top of Apache Lucene. Before Atlas, for example, in one of my previous jobs, we wanted to use full text search. It wasn't accessible in core MongoDB server, so we had to replicate data to Elasticsearch. So we had kind of data duplication. Our MongoDB cluster had, I think, around 4 terabytes of data, and we had to almost everything had to be replicated via a tool called Monstache to Elasticsearch. And application was talking to MongoDB and to Elasticsearch. So some queries went to DB, some queries which are related to full text search went to Elasticsearch. It wasn't very nice. Also, we had to monitor replication between MongoDB and Elasticsearch, because you can have data inconsistency if there is some problem with replication. And Atlas is a solution for this, because MongoDB natively, in Atlas, MongoDB will take care about this replication between data which is in MongoDB and data which will be in Apache Lucene index. There is additional process, MongoT. This process, MongoT, is wrapper around Apache Lucene, and this is how MongoDB provides you full text search available via Unify MongoDB Query API. So you are querying Apache Lucene index directly from, for example, Mongo Shell. For you, this is transparent for you. You don't need to have knowledge how this data is replicated, etc. And for me, this is huge advantage of Atlas, that you can use this full text search. Also, I know that this solution, it was announced in MongoDB.local in New York 6 months ago. This solution will be this year, I think in 3 or 4 months, will be also available in core MongoDB server, which you are running, for example, in data center. So you will have second process, MongoT. Now you have only MongoD if you are running MongoDB on your server. You will have additional process MongoT. You will need to connect MongoT to MongoD. Data will be replicated some part of data will be replicated in order to create Apache Lucene index, and you will be able to query MongoDB via Unified Query API and get classical queries and also full text search queries together with vector search. Now I'm talking about vector search because this solution is getting very popular for all those RAG related applications like chats, which need some data which came from database in order to provide context to LLM models like ChatGPT. Yeah, so this is maybe, if you want, I can tell more about this.
Yeah, I think it's good to go on about that because I know that a lot of people are talking about RAG and other kinds of things in the AI space. Please go on.
Yeah, so this is actually, I'm building something also with MongoDB and LangChain framework. So this LangChain framework will orchestrate everything for you. So basically, you need to have context to your queries, because sometimes when you talk, for example, with ChatGPT, answers are not accurate. There is hallucination. People call this hallucination. So ChatGPT or any other LL model can give you answer which is not accurate. The best idea to fix this is to provide correct data together with your query to those models, and then those models will use your data, will use your query, and will generate correct answer for you. So for example, if you want to build some chat in your company based on your company data, you can use vector search, you can vectorize your data, you can store this data, for example, in MongoDB now, because currently it supports vector search, but soon this will be also available with core MongoDB server. You can then, with the help of LangChain, because MongoDB doesn't support vector creation, you need to first send your data to some LLM model like OpenAI embeddings API, and this API will convert your data to vector. This vector have to be stored in vector database. And then if you want to query this vector, you need to vectorize your query, also with help of some embedding API. Next step is to make vector search. So vector database like MongoDB will compare your query to vectors which are already in database, and will choose the most sufficient results. So this will be kind of semantic search, because vector search is comparing vectors, which are numerical representation of data, to other vectors. And result of the query will not be exact match like in classical database. Result of your query will be collection of vectors which are very close to your original query. And this data, query itself, together with documents which are matching to your query have to be sent to LLM model as a context. And based on this data, your model will give you very, very good answer based on basically on your single source of truth, which is your vector search data. I'm building something like this in my company. So we are building chat, which will be answering newcomers all questions which they are asking us at this moment, because we are seniors. We have some newcomers, and those people will ask 100 questions. Now we have first version of chat, which is using vector search, and if they are asking question, first vector comparison of question will be done in vector database. Then this query will go to some LLM model which we are running locally, and answer will be provided to newcomer. So this will also save our time because we can do other work, not which is different than answering always the same questions. But I can see much more use cases for this pattern, and I think many of them will pop up in near future.
Okay, it's good to hear. I'd like to touch a little bit on, it sounds like MongoDB's got a lot of great things coming for it. We talked a little bit before the show that there's some things that MongoDB is not so good at. So can we talk a little bit more about that, just to make sure that people don't choose something that may not quite fit their use case?
Yes. So, for example, if you have large scale historical data and you want to run some analytical queries, MongoDB maybe is not the best choice for this. For example, in my company, we are replicating data to BigQuery from MongoDB. Because BigQuery will be better for all those analytical workloads. In MongoDB, you have aggregation pipelines. They are good for some analytical workload, but I think for a real large scale analytical queries, data warehouses are better, like BigQuery. At least this is what we are using in my work, because MongoDB wasn't good enough for our workload. This is one is not the best.
Sorry, you're starting to go out at the end, so it's not one of the best. So lots and lots of data. We should definitely prefer a data warehouse, data lake kind of solution. You're saying?
Yeah. So this is, you are absolutely correct. For this, which is typical analytical workload for historic data, MongoDB is not the best.
Yeah, and I think you also mentioned something about analytical data would also be like that, but that's also just lots of data to kind of crunch, right? Similar kind of problem.
Yeah. So I would just use different database or replicate data to those data warehouses. This is also possible. For example, in my company, we are using Kafka for this. You can use Kafka Connect, and you can stream data from MongoDB change stream to other technology, like for example BigQuery. And I think this is a good way to replicate data from Apache Kafka and those which are dedicated to MongoDB, and you can use those connect.
Okay. Now, the other thing that we talked about before the show, because I remember reading a long time ago, and I asked you about this, the requirements for running MongoDB, right? If you want to run your own version and say not run on Atlas, that is actually gone down from before, because maybe this was pre ACID compliance. I remember that they said, okay, we recommend that the size of your database also dictates the size of your RAM, because basically, my understanding was that MongoDB kind of stays up in your RAM and it works all in RAM, and that it just flushes to disk once in a while, right? Not after every single write necessarily, but because we have a lot of writes coming in, it just kind of batch writes these kind of things. So you said that's not the case anymore. So do you mind to talk a little bit about, you know, the the requirements for running MongoDB on your own, hardware wise?
Uh, yeah, of course. Actually, so the best recommendation is to have your workload still in memory. So this is indexes, your working set, your indexes, and your most recently used data. And this is still also in SQL databases. This is still the best practice because memory is much faster than disk. So you still want to have your most recently used data together with indexes in memory. However, MongoDB 8.0 will consume less memory for the same work set. So, for example, in the past, you would need to have, 32 gigabytes of free RAM for MongoDB Tiger, and now this will work with 16. Yeah, so this is now you need less memory, but still your working set should fit this memory, because this is physics. Read from memory is much faster than read from disk, because all those input output operations, when database is reading data from disk put to memory, and then from memory it goes to the user, this takes a longer time than query directly from memory. So you still want to have your working set in memory. However, now MongoDB changed something in architecture that you need less memory for the same.
Okay, that's a good thing to hear. People who have actually tried to run it in the past and found it to be a little bit more resource intensive than when they would require, and then they really want to have to run. There's just one last thing I wanted to cover, and I think it's quite important to cover. Is you talk about Atlas, right? So a lot of people are running on AWS. I believe AWS should still be offering a version of MongoDB. MongoDB, I remember, didn't like what was happening, and so now they have their own kind of version of Atlas. And they always had their own version, right? Do you mind to kind of talk about, Atlas versus US version, and if you want, you can go ahead and touch on kind of the drama between there if you if you want. It is kind of an interesting thing because yeah, that's caused a big stir and affected a lot of other databases out there too.
Yeah, so AWS, they have also document database. Actually, they call this document database, and this you can use JSON for storing data in this document database. You can use MongoDB query language to access this data, but this is very basic if you compare to MongoDB. It doesn't provide you many MongoDB features. For example, you don't have change streams. Obviously, you don't have sharding. And I don't really know if if this database is popular. I have never seen company which is using this AWS document database. This is kind of limited version of MongoDB, and I think that's why MongoDB changed license years ago, because cloud providers was using open source database for their own purposes. And I think similar thing happened to Elasticsearch, and then AWS created OpenSearch. Yeah. So this is a very, very funny story. But yeah, there was an issue. However, now I think there is a partnership between AWS and MongoDB, and you can have Atlas accessible from AWS Marketplace. So you can very easy connect Atlas. You need to do VPC peering with your applications which are running on AWS. And then Atlas provides much more features than basic AWS document DB. Maybe this document DB is good for some test use cases or for some very simple key value store. But if you want to really use DB, rich number, full text search, also now stream processing, because MongoDB also that stream processing to Atlas, you definitely wants to use Atlas. I just want to mention that there is also free Atlas cluster available. So this is M0 cluster. You can test this absolutely for free. You don't need to even put your credit card. You only just log in and can use this Atlas cluster. I saw that vector and full text search is also available. in M0 cluster. So I think, this is the best way to get started with this. And apart from this, if we think about other cloud providers, I think GCP doesn't have anything which you can compare to MongoDB. On Azure, you have Cosmo DB, but I don't really have experience and knowledge about this database. I know that something like this exists. However, Atlas is also available on Azure and GCP and AWS. So I think this is, if you have really production use cases, you would choose, you will still choose Atlas. You will just do VPC peering between your application VPC and Atlas VPC, and then you can have secure encrypted connection to your database.
Okay. Yeah, I don't think I have any more questions on my side. Is there anything on your side that you think that we missed, or shall we start to wrap up?
I think I also want to mention about Atlas CLI. I like this tool because you need to use Atlas cluster if you want to test Atlas cluster, and he doesn't want to use this cluster in the cloud. You can use Atlas CLI, which will download Docker image of Atlas locally, and you can run this for test purposes on your Mac or your Windows. Yeah, I think I found this tool really useful. You don't need to. This is like CLI for local Atlas cluster. You can test your basic functionalities. You can start learning from this point. Actually, I put a chapter in my book about running Atlas locally with the help of Atlas CLI. So if someone wants to learn about all those features, I highly recommend to check this book because I think I put everything which is really new to MongoDB to this book. So like 50% of the book is about core MongoDB server, and other 50% of the book is about Atlas, about running Atlas locally, running Atlas in cloud. And also I have one chapter, last chapter, is about running Atlas with the help of Kubernetes. We spoke about Kubernetes before, and I just want to mention that there is operator which you have to install on your Kubernetes cluster, and you can manage your cloud Atlas cluster directly with the help of kubectl and YAML Kubernetes manifest. So you can specify desired state of your Atlas cluster in Kubernetes format and just apply this, and operator, which is running on Kubernetes, will connect via API to Atlas and will create your cluster. You only need to store your API key to Atlas as Kubernetes secret or in some other tool like Vault, from where Kubernetes can get your API key. And then, if you want to learn more, please check this book.
Awesome. Yeah, that sounds good. I haven't had a look at Atlas too much. That I just knew that it was their own provider. I didn't know they offered so much more features. It's quite common for DB providers to have their own hosting as a way to, how do you say that, kind of help with costs, right? Because a lot of times MongoDB Community Edition, right? But then you also have Enterprise Edition sometimes, maybe. I'm not too sure if they still have that. But yeah, and then having this Atlas version sounds really interesting that you have even more features. And I'm always a big fan of letting the cloud try to run as much as possible because it is a pain to, run your own version of a database, especially, you don't want to be able to handle scaling and upgrading and all that kind of stuff. So that's pretty cool.
Yeah, I just want to say that you are right. It simplifies everything. I work with MongoDB since 2016, so it was before Atlas. and I know how much work I had in order to set up everything, monitor everything, make sure everything is running correctly, upgrade everything, etc. And with Atlas, I'm only need to take care about query monitoring and schema basically because Atlas automated everything else.
Well, it's also pretty cool that Atlas has some other features that you don't have in other places. And you said that there's like a free tier at some point, right? So that's also interesting to it that it may be worth it just to try it out because it could be worth it for your application.
Yeah. So this is M0 cluster. It's totally free. You don't need to provide your credit card, and you have almost all features which you will get in paid version because you have other tiers like M2, M5, M10, or M20, and those are paid. You need to pay for them, and then some of them, if you have big data, huge data, maybe you need to optimize them in the terms of costs. But this M0 one is totally free and is the best way to start. Or you can use Atlas CLI and download your Docker image with Atlas cluster locally, and this is also free, and you can develop locally without any cost.
Sounds good. Yeah, if since we're basically just hit the time, I just want to say thanks for coming early. Usually people come just on time, and we had to spend some time to chatter. So it's great to start this podcast recording time on time, and it was also great to hear more about MongoDB. It's been many years since I've taken a look at it, but since so many people are looking at it to store their data for their Flutter apps, thought it'd be a good idea to bring an expert on to talk more about it, pluses and negatives, what you can do with it, et cetera, et cetera. And definitely check out the book. So in the show notes for this podcast, when it gets released, we will have a special discount code and for the code to kind of help us all out. And buy the book directly from Manning because otherwise they have to give a cut to Amazon, and it's better if more money goes into the pocket of Arek in Manning, so they can keep bringing us more excellent authors and excellent books on different subjects. So again, Arek, thanks for coming on, and hopefully we'll have you back on again for the 4th edition of MongoDB in action.
Thank you very much. Actually, this is possible. Let's see what will happen in near future, but this is possible. Thank you very much for inviting. Pleasure for me to talk with you today. And yeah, I will be watching your podcast regularly now because I see that atmosphere is excellent. You are doing a great job.
Oh, thank you for that.